Section 1.4 and the basic rules of algebra. The first objective is to understand and use vocabulary, and we've seen some of this already in the vocabulary algebraic expression, and that was a combination of numbers and variables with operations. So for example, 2x plus 4. To be an expression as opposed to an equation, there's no equal sign. So an expression is just operations such as addition, subtraction, multiplication, and division. Okay, or another example could be 3 times the quantity, 5x minus 8. So we've got some parentheses thrown in here. This is still an expression, not an equation. Now, the terms in algebraic expression are those parts that are separated from each other by addition or subtraction. So for example, in the first example right here, we have 2 terms. The 2x is a term and 4 is a term. In this example here, we also have 2 terms. The 5x and the 8 are both terms. They're separated by a subtraction. The 3 does not count as its own term because it's not separated by addition or subtraction. It's in fact separated by multiplication. So there are just those 2 terms in that one. Okay, so a couple more examples. If we wrote down something like x cubed minus 4x plus 1, there are 3 terms. The terms are x cubed minus 4x, or negative 4x is its own term, and 1 is its own term. So there are 3 pieces. When the term is negative, the negative is part of that coefficient, that part of the term, and when it's a positive number, it's just that number is part of the term. Okay, so another example, negative 5 plus 4x, just making another one up. So negative 5 and 4x are the two terms in that expression. Okay, a term that is just a number is called a constant. So for example, in the previous example, we have 1 is just a constant. It's a term that has no variable component in it. It's just a number. So examples are any number like 1, 3/5, whatever number you're looking at, negative 12, just single numbers with no variable. Now a coefficient, and I used that word a moment ago, a coefficient of a variable term is the numeric multiplier, the number that's being multiplied by the variable. Oops, let me write numeric. That looks like an M, it should have been an N. Numeric multiplier. So for example, in 4x, the term, 4x is a single term, the coefficient of that term is 4. If the term were negative 5x, the coefficient would be negative 5. And if the term were x squared, for example, the coefficient would be 1. You don't need to write the 1 in front of 1x squared to know that it's x squared or that the coefficient is 1. It's the number of variables that you have. So in a term like x squared, the coefficient is 1. Okay? And like terms are terms that are either both constant or have the same variable. So for example, 2x is like 3x. Okay? Or it's also like 7/4 x. It's the variable bit that's the same. If terms are not like, we say that they're not like or unlike. And unlike terms would be, for example, 2x and 3y. Those are unlike because they have a different variable. And that's also unlike for x squared. The variable part is not the same. The variable part in this one is x. The variable part in this one is x squared. Those are not the same thing, so those are unlike. All right, the next example. Use the algebraic expression x plus 2 plus 5x to answer the following questions. How many terms are there? The terms are separated by addition, so there are 1, 2, 3 of them. What is the coefficient of the first term? The first term is x, its coefficient is 1. What is the constant term? 2, that's the term that has no variable. And what are the like terms? So the like terms are x and 5x. Those are like terms, they're both variable terms with the variable x. The next objective, we're going to use commutative properties. So the commutative property of addition says that A plus B is the same thing as B plus A. So when you're adding, it doesn't matter what order you add things up. 2 plus 3, 3 plus 2, both give you 5. Same thing is true for multiplication. A times B is the same thing as B times A. Alright, so what this means is that I can change the order in either addition or multiplication without affecting the product. So in example 2, I'm going to use the commutative property to rewrite these. Y plus 4 could also be written as 4 plus y. And x times 9 could also be written as 9 times x. Now, since I could write these in either order, there is an order that is going to be the normal or preferred way of writing it. And if it's a multiplication problem, we're usually going to see things with the numerical coefficient written first. 9x is the more standard way of writing it. And when it comes to addition and subtraction, the more standard way of writing it is actually to have the variable first and the constant last. So we'll keep those two things in mind. The ones I've circled there are the normal forms, or the way that we're going to see things most often and want to write our answers most often. Okay? So, like I was saying, it's normal to write the variable term to the left of the constant when I have two terms, and I want the numerical coefficient to the left, again, of the variable. So, if I wanted to write this what the normal order would be, I would have to write it as, I need this term first because it has the variable. That's a negative 3x. Then the 7 is positive, so plus 7. Making sure when I change 7 minus 3x around, when I change the order around, that I keep the signs correct. The 3x is the negative part, the 7 was positive, so it's negative 3x plus 7. That would be the normal order, the way I would write that expression if I were writing it down. Alright, the next objective is to look at the associative properties. The associative property says that if you have addition or multiplication, the way you group things doesn't matter. For example, you could add A plus B plus C by adding A plus B first, or you could add them by adding B plus C first. Okay. The same thing is true for multiplication. If you're going to multiply three numbers together, you can multiply the first two together first, then multiply by the last, or you can multiply the last two numbers together first and then multiply by the first number. We do that all the time if we're multiplying constants together. For example, if I'm going to take 3 times 2 times 5, let me rewrite my grouping right here. I could either do 3 times 2 is 6 times 5 is 30, or I could do 2 times 5 is 10 times 3 is 30. The order in which I multiply those three numbers doesn't matter. Okay? So, the reason I would like to have these properties in algebra is so that I can add up like terms. I can't add x plus 5 because they're not like, but if I regroup things, I can add 7 plus 5 plus x, and I'll get 7 plus 5 is 12 plus x. Let me just rewrite one more time. I'm going to start getting in the habit of putting things in that normal order with the x first and the constant last. Okay? So the associative property right here is the property that allows me to add up those two like terms first and then ignore those parentheses. Since it's all addition, it's okay to reorder things. That's what the associative property says. Same thing is true for multiplication. It's okay to reorder these and make it 7 times 4, then times x. I don't know what 4 times x is since I don't know the value of x yet, but I do know 7 times 4 is 28 times x. Okay. Now that again is already in the right order. When I have a coefficient of a variable, I should write the coefficient first. Alright, in example 4, let's rearrange the terms. The numbers can be added. Okay, so I'm going to rearrange these terms to write the variable term first. It's negative 5x. The 7 is positive, so I'll say plus 7, plus 3, and minus 9. Rearranging the terms puts the 7 with the 3 and the 9, and I'm just going to go ahead and add up the like terms, add up those constants. So I'm going to have negative 5x plus 7 plus 3 is 10, minus 9 is 1. That would be written already in the right form. We have the coefficient and variable first and the constant last. Next example, this is a informational piece. When an expression contains both constant terms and variable terms, the variable terms are usually written to the left of the constant terms. Exactly what I've been saying right here. Write the variable terms to the left of the constant terms. So this is what we would say the normal order of writing an expression would be. And we use the term normal loosely, but it's the order that you're going to find things in that you're going to want to be leaving your answers in. Maybe a better way of saying, can't think and write at the same time, maybe a better way of saying it would be the preferred order. Let's look at the next page. The next objective, objective 4, is to use the distributive property. And in the first example, we just want to show that it is true, that this distributive property is going to be true. So I want to use normal order of operations right here to simplify. To simplify, I would get 3 times 6. I would do my addition inside the parentheses first. 4 plus 2 is 6, and 3 times 6 is 18. That should be equal to 3 times 2, which is 6, plus 3 times 4, which is 12, and 6 plus 12 is 18. So those two expressions are equal, and you can see that that came from using the distributive property. The distributive property says that if you have a number, a coefficient of a parenthesis, you can multiply both terms of the parenthesis by that number. So you can multiply 3 by 2 and 3 by 4 and add them up. So A times B plus C is AB plus A times C. Alright, and we saw from the example 5 above that it is true with numbers, so it should also be true with their algebraic expressions. So let's look at example 6. This is the case where I really need to use the distributive property because I can't just subtract inside the parentheses. I can't take x minus 2. So I'm going to use the distributive property and multiply 3 into both of those things. 3 times x is 3x minus 3 times 2 is 6. I've distributed. It's already in the right order, so it's done. Let's distribute over here as well. I'm going to multiply 2 by both things inside of the parentheses. 2 times 4x is 8x. Multiplying the coefficients, 2 times 4, keep the x, and 2 times minus 5 is minus 10. It's already in our normal order, so it's done. Okay. Now, the distributive property can also take other forms than the one that was given in the box above. As we've just seen, we can do the distributive property over subtraction. Another example of that right here, 5 times 4x. So I'm just going to be multiplying the 5 times the 4x, like I've already seen, minus the 5 times the 3 for a simplified version of 20x minus 15. Alright, and again, it doesn't necessarily have to be 2 things inside of the parentheses. We can go ahead and distribute over 3 things. So in this example, it'd be 4 times x plus 4 times 10 plus 4 times 3y for a simplified answer of 4x plus 40 plus 12y. Okay. And in the last example right here, we're just saying that the distributive property works left or right. If I have a number on the right side of the parenthesis, I can multiply into both of the terms of the parenthesis as well. So it's okay. It doesn't really matter if you have it on the left or the right. It works the same way. I'm going to multiply that 9 times x and that 9 times the 7 for the simplified answer of 9x plus 63. Alright, we'll stop here.